Hi, Mr. Novak here. A student has asked me to help him with question 2 part B from his revision exercise. But first of all, I think I'll do part A just to demonstrate maybe a different strategy. So remember, you've been asked to complete the square because when you look at the middle term and the last term, as you can see, you'll never get the factors of 4 to add up to plus 6. That's why you've been asked to complete the squares. Now, what you're basically doing is you're actually taking the first two terms only, x squared plus 6x, and you want to complete the squares, which remember, a perfect square will always give you a constant which is positive. We're just trying to find out what that value is. And as I say, we're going to create a perfect square for the first two terms given. That will obviously be plus 3 because remember, when expanding this, we multiply the 2 and double it. So going the opposite way, we halve it. Now, to get the constant, of course, we square the first term, that gives us our x, and we square the second term to give our constant, which in this case is plus 9. As I say, it's always positive. Now, here's what we want to make sure. We want to make sure that all of these three lines are exactly the same. And clearly, the first two lines are not. So, what do we need to do to this line, middle line to make it the same as the top line? Of course, we need to subtract 5. And remember, the x squared plus 6x plus 9 becomes that perfect square, so we need to also transfer that minus 5 down below, and we now have completed our square. So we're now using the null factor law, and of course we're using DOPS, and what we want to do is create the difference of perfect square, and as you say, the little trick there, which is, of course, is x plus 3, x plus 3. We want 5 as a surd, so that root 5 squared it gives us our difference of perfect square, so that's plus root 5, and the other one must be minus root 5. And therefore, for the null factor law, remember it's got to be the opposite of plus 3, which is equal to minus 3, and the opposite of the root 5, in this case a minus, in this case a plus. And that, of course, will give us either side of the minus 3. So that was completing the square when the middle term is even. Now, why the students has asked for the part B, because that's the challenge. The fact that we have a odd number. So let's have a look at that one. So we have x squared minus 3x minus 3. Again, we know that the factors of minus 3 will never add up to minus 3. And in year 11 and 12, you're expected to recognize that this is a completing the square. So again, we're taking our first two terms. We want to create a perfect square. So we have the x. We need half the middle coefficient, which in this case is minus 3 on 2. Remember, when we multiply those two together and double it, we'll end up with minus 3x. But in doing so, we create an extra term on the end here, which in this case is 3 over 2 squared, which is 9 over 4. Once again, we want each of these three lines to be exactly the same. We'll put the 0 on the end there, because we are completing the squares to work out the x-intercepts of our quadratic. All right, so let's have a look. We have minus 3, and here we have plus 9, 4. So we have to obviously subtract. Well, what is it we have to subtract? Well, before we can do that, let's convert the 3 into quarters. So that's going to make that 12 over 4. So we now have minus 12 over 4, and here we have plus 9 over 4. So we must subtract, let's see, try that, minus 21. Let's double check. 9 take away 21 is negative 12. And so we have now negative 21 on 4. Again, we want to set up a complete, the difference of perfect squares. So we need to take this 21 on 4 and turn it into a perfect square. So we square root that, which is root 21. We square root the 4, and we get to, let's double check. Root 21 squared is 21. 2 squared is 4. We now have the difference of perfect squares. So we have x minus 3 on 2 is our first part of the brackets, and the other one is the plus or minus root 21 on 2, or minus root 21 on 2. And of course we're using the null factor law, so the x-intercepts will be at minus 3 over 2. Opposite of that is positive 3 and 2, and the opposite of plus or and minus is minus and plus, which we now giving us root 21. I hope that helps you look at completing the squares in a slightly different process. Of course, it may be the same as your teacher if you don't have me. Have a great day, and I hope you can do well on the test coming.